Hey guys, welcome back. Now this is a new playlist of machine learning, and in this playlist we will describe the theory of each and every algorithm. We'll talk about the mathematics behind the algorithm, and we'll see what are the codes that are involved when we'll code the algorithms from the scratch. Okay, so let's get started. So first thing comes first. The first question is, what is machine learning basically? So what is ML? This is the most important interview question also when you will apply for a data scientist job or a machine learning engineer job or for an AI engineer job. Then you will be asked this question again and again. What is machine learning actually? So you can answer this question as the machine learning is the study of algorithms basically related to artificial intelligence. So the machine learning is study of algorithms related to artificial intelligence. Those algorithms are capable of automatically changing themselves or improving themselves, okay, by using the experience that they have. Okay, so by using the experience, the algorithms are actually able to change themselves so that they can produce better outputs. So the machine learning is nothing but a field of study of artificial intelligence algorithms that are capable of improving themselves automatically with the help of experience. Okay, so this is the proper definition of machine learning. Okay, then next question that comes in the mind is, what are the different types of machine learning? Okay, so if you'll see that there are three different types of learning techniques available in the machine learning domain. Okay, so if you'll see that there is supervised machine learning, there is unsupervised machine learning, there is reinforcement learning. Okay, so when we talk about the supervised machine learning, what happens that we are provided with some data, okay, and the data will have input and the labels. So labels will be output. So we'll be provided a data in the form of let's say table. Okay, so there will be some independent attributes and there will be some dependent attributes. So this will be label and this will be attributes. Okay, so so whenever you get a data in a tabular form, it is nothing but structured data, and whenever we get a data like some images or some signal like voice or some other time series data that is not very well structured, then we say so all these things, all these types of data are basically here covered in this. When I say that we are given some data, so some data is given and some output or labels are given for the data, and we pass that data to an algorithm, to your system, an algorithm, and the algorithm then creates a model. And after creating this model, this basically becomes the formula, or you can say the knowledge for the machine. Okay, and whenever it will be given a new input, that is a data without output label, then the model is capable of producing the output. Okay, and so you can see that the main difference between the supervised and unsupervised learning is this output label. In unsupervised machine learning, what happens that we are given the data and we are not provided with any label. So output will not be given in the unsupervised machine learning during the training. So this phase when we give data to algorithm and algorithm makes a model, creates a model, this whole phase is known as training phase. Okay, so in training phase, what happens, we are not giving any kind of output or any kind of label. Like here we will not give this Y label, we'll just give the data and we'll not say what is the data, or what are the categories for the records available in the data, or what is the prediction value for the x, for the given x. We will just give the attributes. Only raw data will be given to the algorithm without the labels or without the output, and the algorithm will create a model that will be able to cluster, to basically divide that input data into some groups, some similar groups. That similarity may be based on some spatial positions of the data, or it can be similar in other sort of matrices. Okay, but it will be able to cluster the data. It will be automatically be able to make groupings out of the data. So in this type of basically learning, where the algorithm is not provided with the output, and it is capable of designing a model which will be able to group the given data in particular clusters or groups, okay, is known as the unsupervised learning. So basically output is not given in unsupervised learning, and in supervised learning output is given, output or labels are given. Okay, so you can see in the later parts we'll see what are the supervised and what are the unsupervised algorithms, and what are the examples. Supervised algorithms, supervised machine learning algorithms contain linear regression, logistic regression, okay, SVM is there. Okay, so all these algorithms are supervised machine learning. They require output labels and input data. And unsupervised machine learning algorithms can be k-mean clustering. So basically this is the clustering algorithm. So we'll talk about these algorithms in detail in later videos. Okay, now let's see the third category of our machine learning algorithm. The third category is reinforcement learning. So what happens in reinforcement learning? Data is given to the machine, it creates the model, and the machine itself is able to communicate with the environment. Let's consider a practical example here. So let's suppose we have 6 balls here, okay, and we are throwing these balls, and these weights of the balls is 1 kg per ball, okay, kg per ball. Okay, so we are sending these balls to a machine, okay, and machine is basically let's say counting the balls. Okay, let's say that machine is basically measuring the weight of the ball. What are the weights that a particular, what is the weight that a particular ball has? Okay, so it will provide some sort of output. Okay, so you see that here machine is not able to get the weight of this container. So this is environment for the machine. If I somehow connect this environment to the machine, and I can provide some feedback after giving an input, when output is produced by the machine, if the machine can sense the environment, that when after producing the output, what are the changes that the environment is having, then it can accommodate itself to do some better predictions. Maybe it can calculate the difference between how many balls have been received by the machine and what can be the remaining balls in the tray. Okay, so basically what happens in machine learning, we give a data to the model, it produces the output, and output influences the environment. In reinforcement learning, we are given a feedback from the environment itself to the model, so that model can mutate itself, it can change itself to perform better in predicting the outputs. Okay, so this is a very vague definition. I hope guys you have learned something out of this 10-minute video, I guess. So if you like this, please subscribe to the channel and just follow the upcoming videos, because there will be a lot of things that we'll be discussing, and we'll be coding each and every algorithm from the scratch. Also I'll be talking about the mathematics that is involved behind the scene of machine learning, and we'll be talking about the interview questions that are most potent to come during your interview session. The potential questions will be discussed, and the answers will be provided in a great depth. So thank you for watching. Okay, bye.